In this video, we'll learn about VHDL, how to code in VHDL, and semantics of VHDL. So VHDL is used to design hardware circuits and testing hardware and circuits. It supports modular programming like C++, so you can expect something like defining a class in C++. So we over here we have entities, components, which you can think of as classes in C++, which makes this programming language modular and powerful. So in this tutorial, we learn how to design a NAND gate in VHDL. So I've created a file called nandgate.vhd, and note that the extension of the file is .vhd, which stands, which is the extension for VHDL files. The next thing that we'll do is these two lines. So think of these lines as hashtag include iostream of C++. Uh, yeah, so you can think of these two lines as those. Uh, the next thing is how do we define or design NAND gate? So designing any circuit or any gate in VHDL, you can break them down into two steps. The first step is define an interface, and the second step is to define the behavior. Oh, and by the way, like comments in VHDL, they are done by two minuses, right? So yeah, so what do we mean by define an interface? An interface can be thought of as defining an interface can be thought of as defining the inputs and outputs to an entity. So we have to specify what are the inputs and outputs to an entity. So for example, in a NAND gate, we would like to design a two input NAND gate. So you do that as follows. So entity NAND gate. So this is the name of the entity. You can name it anything. I named it as NAND gate. Entity NAND gate is, and you specify the inputs and outputs. So how do we do that? We specify a port and say the first input is X. So since it's an input, I'll write IN and I'll specify the data type. So for data type, I'll be using std logic. So for now, think of std logic as a bit. Uh, the next input is say Y, and it's an input, so I'll write in, and its data type will be std logic, which you can think of it as a bit. And note the semicolons after these. The third thing is the output. So output, let's say it's Z, and it's out. So I denote the output by out, and the data type will be again std logic. But there'll be a semicolon after this over here. Like there's no semicolon over here, just after the statement. So that's pretty much it about defining the inputs and outputs. So we can just end our entity over here, end entity. Yeah. So that's pretty much about defining the interface for a NAND gate, which specifies the inputs and outputs to a NAND gate. But if you look at it, like the code doesn't know how is Z related to X and Y. It's just defining an interface. The main logic part of how X and Y combine to give you Z, that's still missing. So that is what is done in defining the behavior. So in behavior, you just specify how are X and Y related to Z. So that is done by defining the architecture of an entity. So architecture, so we name architecture, let's call it behavior, architecture behavior of which entity? My NAND gate, which I have defined up over here, is, right? So, so let's think about it. How will we implement a NAND gate? So ideally what we would want to do is, say we would have a temporary variable which will store say X and Y, and say after that you would like to assign the output as not of temp, right? This is what we would like to ideally do when not is the not operator. uh, so yeah, so we need a temporary variable over here. So temporary variables in VHDL are denoted by signals. So signal, so let's define it, a signal temp, and I have to write its data type std logic. So that's the temperature variable we need. And after this, we can just begin our architecture. Begin. Now, let's assign our signal temp with x and y. So signal assignment is done using this less than equal to, and is the keyword for logical and. And after this, we would want to do z is not of temp. Uh, yeah. So yeah, and let's just end the architecture over here. So that's pretty much it about defining the behavior of a NAND gate. So you can think of this as defining the entity as just writing a declaration for your class and like defining the class variables and members. However, the architecture can be thought of as actually defining the functions and yeah, functions outside the class, like just trying to give an analogy to C++. But we still need to test this AND gate, like whether everything is correct or like, yeah, whether everything is correct. So that will be done by using a test bench, what we call the test bench. So the next video will be related to test benches and how we test entities using test benches.